Another neat bit of functionality in the Max versions of the MIAP objects is trajectory control. And this is something that is a really important part of SpaceMap as it's used by sound designers in the Meyer version of the software and hardware for large multi-channel sound pieces. And something that's been there from the beginning in the Max objects. I've refined it a little bit. The latest version of the software has some extra bells and whistles. So now's a good time to talk about it. This stuff isn't in the PD versions of the objects yet. Trajectories, essentially, if you've used max line and line tilde, are like a two-dimensional version of those linear interpolators. It's essentially just a way to script a movement in this two-dimensional space, either through, and I provided a scripting language of message syntax, and I've also provided a way to automatically record your movement with the mouse, and that's a new feature as of version 1.2.1. And then to transform those trajectories, rotate them, scale them, offset them, scrub through them, change the rate of playback, go forwards and backwards, and all that stuff. It's really full functionality. It's nothing, it's stuff that is done in other objects in Max, but it's pretty full featured. So it's kind of like a two-dimensional line object on steroids. All right, so let me show you. So over here on the right of the patch, I've got all the different things that you can do. You can if you give it a bang, it starts a trajectory from the beginning. If you press start, it will start or restart something that's been stopped. If you press stop, it will just pause. The position object will scrub through from 0 to 100%, and then you've got a bunch of different things to transform the trajectory. So first thing to do is let's just make a trajectory. There's two ways to do it. One is to use the scripting to explicitly write a message like a line object, similar to a line object that makes a trajectory. And the syntax is different than line. So the way that you specify this is x1, y1, followed by the amount of time it will take to get to x2, y2, then the amount of time it will get to x3, y3, and so on. And the last point doesn't have a time value after. So this is starting at -500 to -500 x and y, and then over 1.5 seconds, this is in milliseconds, make your way to 700 to 300, and then over three seconds, make your way to -200 to 100, and then over 500 milliseconds, go to 0, 0. So if I click that, you see over here on the right, I've got a trajectory that describes this message. So there's a syntax where you can write your own, you can script your own messages. And once we've got that, we can do things to it. So one of the things that we might want to do is just play it. So let's bang. So now you can see it's moving through, and you can see down here on the bottom left the gains are changing, so it's just automating the movement. In between each node you have a time value in seconds that tells you how long it's going to take. So let's say we want to start it again. Now if I press stop, it's paused essentially, and now if I restart from the beginning, I press bang. If I want to start from where I left off, I press start. So you can stop and start from wherever you are. I can also manually scrub through, right? And this grain value is like the grain for the line object. You have to specify what's the minimum, the minimum grain time in milliseconds that you're going to interpolate. Apply this linear interpolation over. So I have it defaulting to 20 milliseconds, but you can change that. More importantly, probably are these other things. So repetitions. By default, it's 1 repetition. If I change this to 2, even while it's, well, actually, if I change it to 2 while it's playing, it's going to stop. Let me restart. And now it will repeat 2 times. Let's change the playback speed to 200%, just so it goes faster. There. So it did it. So I can change that rate on the fly. I can slow it down to 50%. I can go negative. So if I go -100, now it's going to go backwards. And if I change the repetitions to 0, it's just going to infinitely loop. So you can have as many repetitions as you want. You can script those, or you can just say, do whatever I'm doing is over and over and over again while I change the speed. So now it's going to go faster. Now let's go forward at 100%. Now let's rotate it. So here's some other features, and you can apply this and it'll visualize it while you're playing back if you want to. This is something that doesn't happen in the Myers version of the software. So you rotate in degrees. I can offset X and Y, and I can scale. So a negative scale will invert it on that axis. And everything you can do during while it's playing back. And then you can stop it. So you got a bunch of different things that you can do. You can also record the mouse movement. So for that, I've got an attribute called record grain, and this is the interval in time that you're going to capture as you're mousing over, or essentially all you're doing is sending in the chords message to the MIAP object, but you can use the UI object to do that. So as you're sending in these messages, what's the rate at which it's the fastest that it will capture that information? So to do that, open the trajectory authoring window and click Record Trajectory 1. As soon as I do that, it clears the trajectory and it waits. And now as soon as I send my first message, first click, it is going to be tracking the time between these clicks. And if I'm just clicking around, that's the more efficient way to do this. It will track the time, but if I click and drag, you're going to get a lot denser nodes. And then I stop, and now I've got a trajectory. Let's do a simpler one just so it's easy to see. So let me trace around the ring. Oh, and it's visualized in a strange way because I have rotated it and offset it and scaled it. So let's go back. So that's exactly what we just did. So you see there's a lot of nodes. Now let me play it. So if you're doing something like trying to draw a picture, you may want to keep the mouse down and just click and drag, and it will create lots of dense nodes. But if you're doing to achieve essentially the same thing with less nodes, you could just click and then time it till the next one, and just wait and wait. And maybe I want to go a little faster here, 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 and then slow again. And that's going to achieve a similar thing with less nodes. So once you've got trajectories like that, you can write them. You can also read trajectories. It writes them to a JSON file format similar to the maps. And by the way, you can also export trajectories from Meyer project files. So in the MIAP.Meyer object, there's also a trajectory message, and it will show you the loaded trajectories, and you can write the trajectory just like you write the map. So you can load in a trajectory, select the right one, and then write it to a JSON file, and then we can read a trajectory. So there's read trajectory messages and write trajectory messages. Let's read one, and that means I've got to find it. Sorry. Okay, so let's load in that. Okay, so it loaded in a new trajectory and from a JSON file, and you can also write it. You can also dump the trajectory, and when you dump it to the max window, I'm printing what it's dumping. It formats basically the JSON file in an OSC-like style so that you can send it over the network. You can do the same thing for maps, by the way. So once you've got a trajectory authored, let's author a new one. Let's just do that guy. Or actually, let's just record something. There. Then you can write it to file by clicking Write Trajectory and select where you want to put it. Let's put it on the desktop. And there it is. So the format is, as I said, it's a JSON file that's pretty human readable. Tells you for each node what's the duration and what's the XY location of the node. And that's pretty much it. Again, this is available in the Max objects. The PD objects don't have this quite yet, but it's a pretty useful tool. And for actual practical sound design and authoring spatialization, this is it's a pretty nice feature that I'm glad I finally have implemented, ported over from the Meyer software.